Okay, for section 6, we have systems of equations, which basically just means that we have more than one equation that we're going to be solving at once. I'm not going to do all 4 of these for you because I want you to have some that you have to do on your own. But I'll do the first 2. So for problem 1, we have the equation 2x plus y equals 4 and the equation x minus y equals 5. These are in standard form, which means that there's 2 ways we could solve them, and I'll solve one of them in each different way. So for this equation, 2x plus y equals 4, one way we could solve it is by finding the x and the y intercepts. And so I could say that I'm going to take the equation 2x plus 0 equals 4. The 0 would cancel out, give me 2x equals 4, divide by 2, and I'd get x equals 2. And then to find the y-intercept, I would have 2 times 0 plus y equals 4. The 2 times 0 cancels out, and that leaves me with y equals 4. So this first equation, we would have that the x-intercept is 2, and the y-intercept is 4. Then for x minus y equals 5, I'll solve this the other way, which would be to convert it into the slope-intercept form. So in order to do this, I would subtract x in order to cancel out the x, giving me negative y equals negative x plus 5. This negative y would have a negative 1 in front of it, so I'm going to divide by negative 1. And that will give me y equals negative x would also have a negative 1 in front, so those would cancel out. Looks like it is reloaded. Yes, we're subtracting x on both sides, and we have negative y equals negative x plus 5 divided by negative 1. So this is going to give me y equals a positive x minus 5, which means I'm looking for a graph that would cross the y-axis at negative 5 and would have a slope of 1, meaning I should be going up 1 and right 1. So let's look for the graph that matches that. First equation, we should have x equals 2 and y equals 4 for our intercepts. So I'm looking for a graph where the x crosses at 2 and the y crosses at 4. And to me, that looks like graph D. Again, these are A, B, C, and D. If I look at graph D, here we have one where the x crosses at 2 and the y crosses at 4. So we'd have x equals 2 and y equals 4. But to make sure, let's make sure that our other equation matches. X minus y equals 5, we turned into y equals x minus 5, where it crossed at negative 5. It goes up 1, right 1. So if you look at graph D, we do have, it crosses at negative 5. If I go up 1 and right 1, I do get another point. So that does seem to match. Graph D will be my answer for problem 1. So then let's check graph B, problem 2. We have y equals 3x minus 2. This one is in slope-intercept form already, so we should know it's going to cross at negative 2. And then the slope of 3 tells me I'm going to be going to the positive. I'm going to be going up 3 and right 1. So I'm looking for a graph that crosses at negative 2, goes up 3, right 1. That looks like graph C here. Crosses at negative 2, goes up 3 and right 1. So that looks like it matches our first equation. Let's make sure that it matches the second one as well. I don't know why some of those things moved. Let's see if I can move them back to where they were supposed to be. Looks more or less. But on problem 2, we're looking to make sure that our second line matches. And so we have y equals negative 2x plus 3. That means that we should be crossing at a positive 3. And our slope of -2 would tell me that I'm going to be going down 2 and right 1. So here on graph C, I do cross at 3. I go down 2 and I go right 1. That means that C is the answer for problem 2. Okay. So the last two I'm going to leave to you to do. Good luck.